The following demonstration involves three applications: App 0, App 1, and App 2. App 0, the Multiboot application, is responsible for managing the boot process of the different firmware images stored in the device's memory. App 1 and App 2 are two test firmware images that will be managed by App 0. The figure shows the layout of the applications in the device's flash memory, with up to 128 kilobytes allocated to each. In the case of App 0, it includes a segment called Boot 2, which is inserted during firmware compilation using the SDK's default linker configuration. Boot 2 handles the initialization of the external flash interface. As a result, after App 0 has been executed, its inclusion in the other applications is no longer required. The linker script is the key component for defining the memory layout. A separate script must exist for each application, and CMake must be instructed to use it during the build process. As a result of the compilation process, 3 UF2 files are generated, one for each application. The UF2 format is designed for loading firmware onto microcontrollers via a USB connection. An interesting feature of the UF2 format is that it allows the three applications to be written sequentially without causing address conflicts or overwriting. Let's now run an experiment with the Multiboot system using the RP2040-0 board. The board is connected to a laptop via USB for power supply and firmware uploading. The UART port of the RP2040 is connected through an FDDI adapter, enabling applications to transmit messages to a serial terminal. Finally, an LED is added so that each application can identify itself with its own blinking pattern. Let's walk through the following steps to test the Multiboot system in action. Load app 0.uf2, the Multiboot application, and verify that it runs correctly. Select option 0 to take a look at the flash memory at the addresses corresponding to App 1 and App 2. It is confirmed that no firmware is present at the App 1 and App 2 addresses. Now load App 1.uf2, the test application, and verify that control initially returns to App 0. Select option 0 to take a look at the flash memory and confirm that firmware is now present at the App 1 address. A detailed analysis shows that the stack pointer is located in RAM within a region called Scratch. This is correct according to the configured memory layout. Finally, load app 2.uf2, the second test application, and perform the same verifications. Now proceed with the final validation. Select the test applications from the main Multiboot application. Start from Reset and select option 1 to launch App 1. Excellent. Serial messages from App 1 appear, and the LED blinking pattern changes accordingly. Now start from Reset and select option 2 to launch App 2. Eureka! Serial messages from App 2 appear, and the LED blinking pattern is updated as expected. Thanks for watching. If you liked the video, don't forget to hit that like button.